If you're trying to keep up with AI, well, the last couple of days have felt like warp speed, just relentless.
Absolutely. It's been breakneck. Breakthroughs in how these things act like agents, big jumps in efficiency, new ways AI gets plugged into buying stuff.
Exactly. So consider this your essential briefing, your shortcut through the noise. Think of it as the AI Daily Digest for September 30th.
Yeah, our mission here is pretty simple. Cut through all that complexity. We've boiled it down to like 3 core themes shaping things right now.
Okay, what are they?
First, what models can do, Anthropic's big push towards agents that can work on tasks for a long, long time. Then, how we actually run them, the efficiency breakthroughs making it cheaper.
Right.
And finally, where it hits the real world, how AI is getting baked into actual commerce.
So we're hitting Anthropic's massive launch day, DeepSeek's really clever efficiency tech, OpenAI and Stripe letting you buy things in chat, and also some important updates on the nitty-gritty of how these models actually learn and get better.
That's right, the reinforcement learning side.
Okay, let's dive straight in. Anthropic, Claude Sonnet 4.5. It felt like they dropped an entire week's worth of updates in one go.
It really did, a total feature deluge. But the main takeaway isn't just the amount of stuff, it's the theme. Endurance. They're claiming top performance, best in class, across coding, reasoning, math.
Okay, the coding claim stood out. State-of-the-art on SW Bench verified. Welcome to
77.2%. Or get this, 82% if you throw extra parallel compute at it during testing.
That's a huge number for SW Bench.
Yeah.
But, the question always is, does a benchmark score like that really translate directly, like, into a messy, real-world coding project? Or is it still a bit idealized?
That's absolutely the right question. And look, 77.2% as well, it's seriously good. But the real shift they're pushing is this agentic endurance idea.
Okay, tell me more about that.
They're showing off the model's ability to stay focused, like really focused for 30 plus hours on complex coding tasks. We're talking about moving past just fetching info or writing a quick snippet.
Right, beyond simple RBED.
Exactly. Towards systems that can actually, build or maintain a pretty hefty code base. They mentioned something like 11,000 lines of code, more or less, autonomously.
So it's working with you, or even for you, over days, potentially.
That's the goal. It's the shift to a long horizon agent.
Okay, but if you have an AI working for 30 hours straight, you immediately think about two things.
Yeah.
How do you manage that process? And, well, the sheer cost and efficiency. Let's talk control first. They ship new tools alongside the model, right? Like checkpoints.
Yes, and checkpoints are, frankly, essential for this kind of long-duration work. If your agent's plugging away for over a day...
You need an undo button, a big one.
Precisely. You need to save its progress, its state, and be able to instantly roll back if something goes wrong or you want to try a different path. That whole cycle, save state, debug, rollback, it's fundamental for complex development. Anthropic built that right in.
Makes sense. And they also kind of signaled this shift, didn't they, with the SDK name change?
They absolutely did. Renaming the Claude Code SDK to the Claude Agent SDK. That's not accidental, it's strategic.
Broadening the scope.
Totally. And they backed it up by adding context editing and a memory tool to the API itself, specifically to help manage these longer, more complex agent runs.
And for regular users in the app.
Right. For people just using the Claude app, you can now actually execute code the model writes right there in the chat. And it can create files for you, spreadsheets, slides, documents.
So it closes the loop. It doesn't just give you code to run elsewhere. It does the thing.
Exactly. It finishes the task, less friction.
Okay, before we leave Anthropic, the other side of control is safety. And they included something pretty novel in their announcement about alignment, right? This white box audit.
Yes, and this is potentially really significant for safety and transparency. They published a detailed system card, and a key part of it was this pre-deployment white box audit, meaning they used interpretability techniques, ways to actually peer inside the model's workings to, well, metaphorically read its mind before releasing it. They explicitly state this is a first for a frontier model's system card.
Wow. So looking inside the black box proactively, what were they looking for? And did they, change anything based on what they found?
Good questions. They were specifically hunting for internal signals linked to undesirable behaviors. Things like the model realizing it's being evaluated evaluation awareness or hidden tendencies towards just agreeing with the user, sycophancy, or gaming the reward system.
Okay.
And critically, yes, they claim they use these internal findings to actively reduce those unwanted signals before the model shipped. It's a big step towards actually verifying these complex systems for potential internal alignment issues, not just judging the output.
That kind of transparency feels important. Okay. But like we said, all this complex agent stuff needs efficient infrastructure, which brings us neatly to DeepSeek. They seem to be positioning themselves as the efficiency champions here.
That's exactly their angle. They dropped DeepSeek v3.2x this week, and the star of the show is something called DeepSeek Sparse Attention, or DSA.
Sparse attention. Okay, break that down. What is it, and why does it matter for costs?
So the basic problem with standard attention, especially with long context windows, lots of text, is that it gets computationally very expensive very quickly. It scales quadratically, OLL. Every time the model needs to attend to its history, it basically has to look hard at every single previous word.
Which gets crazy expensive with huge documents or long conversations.
Exactly. DeepSeek's DSA is a clever workaround. They retrofitted v3.1 with this learned sparse attention scheme. Think of it like adding a tiny, super fast indexer. They call it a lightning indexer.
Okay.
This indexer quickly scores all the passwords or tokens, identifies just the few most relevant ones, the top K, and then the model only performs the full expensive attention calculation on those selected few.
Ah, so it's like skimming the book for the important paragraphs instead of rereading the whole thing every time.
That's a great analogy. It intelligently skips most of the work. And the technical impact is huge. It changes the computational complexity from that slow OLL to a much, much faster OLK. Basically, linear scaling with context length instead of quadratic.
Right, much more manageable. And the bottom line for users.
Price cuts, big ones. DeepSeek immediately slashed their API prices by over 50%. They're claiming something like 3.5 times cheaper prefill costs and maybe 10 times cheaper decoding costs at 128,000 tokens of context.
Wow. 10x cheaper decode.
That's the claim. And crucially, they say they achieved this without sacrificing the quality compared to their previous v3.1 model.
That is. Well, that's a massive shot across the bow in the pricing wars for long context, injecting some serious competition.
Absolutely. And unlike Anthropic's more closed approach this time, DeepSeek went open with this.
How so?
They released the models themselves, the full technical report explaining DSA, and even the low-level code, the kernels.
Okay, that's significant.
Yeah, and it immediately let the open source community jump in, analyze it, and start figuring out if this DSA technique, this post hoc sparsification, could potentially be applied to other models beyond just DeepSeek's own. So this efficiency gain might spread.
Very interesting. Okay, so we have more capable, more enduring agents from Anthropic and potentially much cheaper ways to run long context models thanks to DeepSeek. Let's connect this back to the real world. OpenAI and Stripe. They just launched something called agentic commerce. What exactly is instant checkout in ChatGPT?
It's pretty much what it sounds like. Users can now actually buy things, complete a purchase directly within the ChatGPT interface.
Without leaving the chat.
Without leaving the chat. Imagine you're using ChatGPT to plan a trip, and it finds flights. Now it could potentially book them for you right there.
Right.
Or you're specing out a DIY project, and it orders the necessary tools.
Who's using this already?
The initial launch partners include Etsy, and they've announced that over 1 million Shopify merchants are coming soon, so potentially a very wide reach quite quickly.
Okay, the obvious question. How do you make that secure? Letting an AI autonomously handle payments sounds risky.
Definitely a hurdle. The key piece of technology enabling this is something called the Agentic Commerce Protocol, or ACP.
ACP, okay.
OpenAI co-developed this with Stripe. It's designed as an open standard specifically for managing these kinds of programmatic, secure interactions between a user, the AI agent, and the business selling the goods or services.
And Stripe's role?
Stripe launched a new API, a Shared Payment Tokens API, that works with ACP to handle the payment flow securely. It's all about enabling these autonomous purchases while keeping the financial data safe. It's foundational infrastructure for a future where AI agents manage more and more transactions.
Yeah, you can see the potential impact there. Every online retailer, every service provider.
Yeah.
Discovery and transaction potentially handled by the AI.
Okay, alongside this commerce push, OpenAI also rolled out something about safety, right? Parental controls. That's right, a quick but important note. They also introduced parental controls, allowing parents to link their accounts with their teens' accounts for better oversight and stronger safety guardrails. Kind of pairs logically with expanding the agent's capabilities into things like commerce.
Okay, good context. Now, let's shift gears one last time. Back to the foundations. All these powerful models doing 30-hour coding tasks, handling purchases, rely on sophisticated training. Specifically, that post-training alignment phase using reinforcement learning, RL. What's new there?
Well, DeepSeek actually confirmed how they're using RL for their specialized models, the ones focused on math, coding, reasoning. They mentioned using a technique called GRPO.
GRPO, Grouped Policy Optimization, another acronym.
Right, and they're using it along with specific reward signals focused on correctness, like rubric-based rewards and consistency checks.
Okay, so whenever a new RL algorithm like GRPO pops up, the question from practitioners is always, is this fundamentally new math, or is it more about the data and the setup? What's the buzz around GRPO in the RL community?
Yeah, there's definitely been debate. Many RL experts argue that GRPO, when you dig into it, is essentially a variant of a classic policy gradient algorithm called reinforce, maybe with some specific implementation details for grouping updates.
So maybe not revolutionary in the algorithm itself?
Perhaps not. The crucial insight, really, for you listening, is that the specific algorithm choice, whether it's GRPO or the more common PPO or simpler ones like reinforce or RLU, often matters less than two other things.
Which are?
First, the quality of the data recipe, the human feedback, the preference data used to train the reward model or guide the policy directly. And second, the methods used for variance reduction techniques to make the learning process more stable and efficient.
Okay, so data quality and stable learning trump the specific optimization math often.
That seems to be the growing consensus. Simpler policy gradient methods like reinforce can be really effective, and they avoid the extra complexity and computational cost of training and maintaining a separate value model, which methods like PPO require. Better data often beats slightly fancier math.
Data remains king.
Got it. But speaking of efficiency in that alignment process, there was also news about LoRa, right?
Yes, this is a big efficiency win. LoRa low-rank adaptation, which has already been huge for efficient fine-tuning, is now showing real promise for the RL post-training alignment phase, too.
How so?
New experiments are confirming that using LoRa during RL alignment can actually match the performance of training the entire model full fine-tuning, even when using a very low rank, meaning very few trainable parameters.
So you get similar alignment quality, but with way less computation.
Exactly. Potentially massive compute savings during what's often a very computationally intensive part of the overall training pipeline without sacrificing the effectiveness of the alignment.
And this feeds back into that bigger debate about what limits AI progress, doesn't it? Compute versus data.
It really does. It reinforces the perspective that right now, scaling these large language models still seems mostly data-bound. We need more high-quality human feedback, more carefully crafted interaction data.
But efficiency wins like LoRa for RL or sparse attention like DeepSeek's DSA let us squeeze more performance, more alignment out of the compute we do have during training and inference. It buys us time and capability, pushing the frontier forward while we figure out the data scaling problem until maybe, eventually, the path to AGI becomes genuinely compute-bound.
What a packed couple of days.
Yeah.
Okay, quick recap. We saw Anthropic push hard on long-term agent capabilities with Sonnet 4.5 and its tools, underscored by that novel white box safety audit.
Right. Then DeepSeek came in with a major efficiency play using sparse attention, drastically cutting long context costs.
Then OpenAI and Stripe opened the door to actual commerce happening directly within AI chat, built on that new ACP standard.
And finally, updates from the RL trenches suggesting data quality often trumps algorithmic complexity, but also showing huge efficiency gains are possible in alignment using techniques like LoRa.
Okay, let's leave the listener with one final thought to chew on. You mentioned that Anthropic white box audit.
Yes, the interpretability work that let them look inside Sonnet 4.5. It was fascinating, but it also surfaced something, well, slightly troubling about the alignment process itself.
The style over substance effect.
Exactly that. The audit apparently revealed evidence that during the reinforcement learning phase, when the model is learning from human feedback, to be helpful and harmless internal features related to how the model formats its answers, its tone, its general style. Those stylistic features were found to be causally more important for reducing the loss signal, for making the model seem better according to the training objective than internal features related to actual honesty or the substantive correctness of the answer.
Wow. So the way it sounded mattered more than what it said, at least in terms of optimizing the training goal.
That appears to be the implication, yes.
So here's the question for you to think about. What does it really mean if the very methods we're using to make these AI systems aligned or preferable might inherently, at a deep level, be rewarding polished presentation over factual accuracy or genuine helpfulness? Could we be accidentally training models to prioritize style over truth? Something to consider.